Okay. So if there is no update, probably after our discussion today, you'll be able to maybe have some questions, or maybe if there's any work that you are working on and you like to let us know after the presentation, you can also share it with us. I think today I've seen some new names here, and I'll be happy if they can actually introduce themselves to us. Raya Amada. Hello, Raya.
Yes, hello.
Hello, Raya. Welcome to the live session.
Thank you very much.
Can you give us a quick introduction of yourself and where you are calling from, where you are joining from, and the institutions?
Okay. Okay, well, my name is Rai Idris Ahmada. I'm an assistant lecturer from the State University of Zanzibar, but under the Department of Computer Science and IT, but I have been also involved with the Youth Mappers. So I'm mentoring through the Youth Mappers chapter. Yeah.
Oh, okay. Nice to meet you, Raya.
Thank you. Nice to meet you too.
Thanks for joining us also today. The next person that I see is Slyvana Antha. Please, did I get the name correct?
Hello, can you hear me?
Yes, please, I can hear you, Sly.
Yes, it's Silvana.
Silvana, okay. Thank you.
Okay, you're welcome. I'm from the Blue Economy Research Institute at the University of Seychelles.
Oh, okay. Nice to meet you also.
Same here, thank you.
Oh, okay. So at this point, we would actually venture into what today our discussion on some of the new updates that's actually happening on the platform. So, and with the topics for us to discuss today is in relation to mangrove forest monitoring. Mangrove forest monitoring. All of us know the essence of how mangrove is actually helping us within the continent, because actually mangrove actually, apart from it hosting thousands of species, it also helps stabilize the shorelines, prevent erosion, and also protecting the land and the people who live around those areas. So mangrove is something that's actually of essence to us. And with that, there came the Global Mangrove Watch data sets that actually is helping us to be able to do the monitoring of this mangrove. As I speak now, Digital Earth Africa has now injected the Global Mangrove Watch onto the platform. So if you visit the system, you'll be able to have access to the Global Mangrove Watch. And as part of today's section, we are going to go through the process on how to actually access the data sets. And also, if you come to the sandbox, how you'll be able to access those data sets at the sandbox section. Today's section will actually take us through those processes. So not wasting much time, I would share my screen. Please, can you see my screen?
Yes.
Okay, thank you very much. So this is the maps.digitalearth.africa interface, whereby you actually have the chance to interact with all the data sets that we currently have on the platform. How does one get access to the Global Mangrove Watch? To be able to add it onto the map section, you go to the Explore Map section. So once you click on the Explore Map, at the data catalog section, they are grouped into thematic areas. So under the vegetation section, you are going to see actually fractional cover daily provision and also the Global Mangrove Watch. Today's session is actually focusing on the Global Mangrove Watch. So once you click on this, on the name, on the right section, a detailed explanation of the Global Mangrove Watch will actually be provided for you. And if you want to add it to the map, because I've already added to the map, that's why you see that the icon is minus here. But you can actually, if you want to, it to be plus. So once you click on it, it will add it automatically to the map. But because I've added it to it, that's why you see it removed from map. Okay, so right now that I've added the map to it, according to the legend, you notice that the mangrove is actually in a cyan color. Then at the time slider, you can actually see the data sets, the years that we have for that particular data sets. And we have it from 1996, 2007, 2008, the 2009, the 2010, 2015, and 2016. So those are the years that we have from the Global Mangrove Watch. Having this data, you can actually also switch in between the time. So currently we can zoom to an area around Dakar. So using the zoom in button, you can zoom into that particular area and you can see all the mangrove areas around those coastal areas from the western part of Africa. So you can see all those mangrove areas. And not only that, you can also check the eastern part of Africa, around Tanzania, to the southern part of Africa. You actually see that there are a lot of mangroves that's actually that you actually have across those areas. One great thing about the map interface is you will be able to compare between two different years. So as you currently see, you only have one particular year, which is 2016 here. If you want to, but we can actually do a comparison between 2015, 2016 and other years. So how do we do those comparisons? One of the ways that you can do the comparison is you come to where the Global Mangrove Watch layer is. There's this three double dot there. Once you click on it, you see the compare to pop up. You click on that. And if you click on that, you see that the slider will come here. Then you notice that the layer has also been duplicated. So this one is actually Global Mangrove Watch copy. And the one below is Global Mangrove Watch. So this is the original and this is the duplicate. So we want the original to be on the left, the duplicate to be on the left side, then the original layer to be on the right side. Then we can now switch in between the layers. With the first layer, that's the duplicate one, we will keep it up to 2016 just as it is. But on the one on the right side, we can switch in between the years. You can decide to switch in between the years based on the one on the left or based on the one on the right. But for this tutorial purposes, I'm going to use the one on the right to be switching in between. So what you know is that the one on the left-hand side of the screen is 2016. Then the one on the right-hand side is going to be the one that I'm actually going to switch in between. So I'll click on it here. Then I will switch it to the 1996 year. So once I click on the 1996, the images on the right-hand side will change to the 1996 layer data sets that we have on the platform. So having the comparison tool, you will be able to actually switch in between. So let's zoom in again to get actually a clear view of what is on the ground. Then right now, let's switch in between the 1996 and the 2016. So as you can see, notice that in 1996, there were mangroves within these areas, but compared to 2016, some areas are actually lost. So having this comparison tool can actually give you an idea of what is actually happening on the ground for these mangrove areas that we have. So as you can see, 2016 of this Global Mangrove Watch, you notice that there were mangroves, some layers of mangroves around this area. But currently, if you come to 2015, some areas have been lost. So the Global Mangrove actually help us to do this monitoring. And having this comparison tool, you will be able to compare and see what is actually happening. But currently, this tool doesn't actually help us to quantify the number of forests mangrove that has been lost. So if you want to do the quantification, how can we do that? That's where the sandbox actually comes in. Before I move on to the sandbox, once I click on the share and the print, a link will be generated for us. And if I click on the copy, I will put it in the chat. And wherever you are, once you click on this link, you will be able, once you click on this link, you'll be able to see what I'm just seeing, just as I visualize it here, whereby I have the slider tree here, whereby I'm doing the comparison between 2 different years. You can also see that. And aside that, we can actually change in between the years. I use 1996 and 2016, which is about 20 years interval. But you can actually change in between the years to see how the mangrove has been faring over the years, whether it is actually being maintained or it is being removed. But if you want to do a further analysis on it, that's when you have to actually move on to the sandbox, because the sandbox, you'll be able to get values out of it to know the amount of mangrove that has been depreciated over the years or has been removed or destroyed over the years. So before I move on to the sandbox section, please, is there any questions someone would like to ask on the map section before I move on to the sandbox part? Okay, then if no question, then let me move straight to the sandbox section. Once you log on to the sandbox, if you are new to the sandbox, when you visit sandbox.digitalearth.africa, you have the interface of the sandbox, whereby you will get the chance to register for the platforms. Please, when you are registering, please provide a valid email address. Otherwise, a verification code will be sent to you. So if the email address is the one that you've forgotten the password, the verification code will go into that email and you won't be able to access the sandbox. But once you get the verification code, you'll be able to access the sandbox and use it at your own end. Once you log on to the sandbox, you actually see a lot of folders listed here. From beginner's guide, data set, frequently used code, real world folder, supplementary data, and you also have the use cases. But the notebook that we are interested to use is actually in the real world examples. So once you enter into the real world examples, there are a lot of already existing notebooks there, but the one today we are interested in is the mangrove analysis. And once you double click on this mangrove analysis, you're actually going to get the monitoring mangrove extent. And this notebook actually uses 2 products. The first product is the Sentinel-2, and the second product is the Global Mangrove Watch. We are going to use these 2 data sets to be able to quantify what is actually happening for a particular area within the mangrove. So the background information actually talks about the Global Mangrove Watch, gives a detailed information about it. Then we come to the description on how this notebook actually classifies mangrove and not mangrove. So once you enter into the notebook, after reading all the description, you can run everything afresh to actually see all the end results. And you can actually do that by clicking on the kernel and click restart kernel and run all cells. So once you click on the restart kernel and run all the cells will run for you. And you'll be able to see the end result of what this notebook actually gives. Before, if you want to change the area or the location of interest, you should do that. And that will actually make the work much more easier for you to understand and appreciate how the notebook actually works. So the first line here is the loading of packages. And if you want to do it manually at your end, you can select this cell and you click on the play button. Once you click on the play button or the run button, it will execute this particular cell for you. Then the next step is to create a local DAS cluster. That actually helps in the loading of the data sets. It makes it easier for you to load a chunk of data sets gradually for you to visualize it and also use it. Then on the cell 3, you would connect our data to the data cube that we are going to use. At the cell 4 is actually the crucial part, the area of interest that you want to work with. So you have to know the latitude and the longitude of the area that interest you want to work with. Then you provide it here. Then you also provide the buffer. Once you provide the buffer and you plot it, it's actually going to give you the extent of the area that you are going to work with. So this is the area that you are going to work with, and it will also display on the map. If you actually want to see the real, you can actually zoom out to see which part we are actually talking about. So we are dealing around western part of the continent, that's Western Africa section within the country there. So once you are there, you provide these two results, then you provide a buffer. The product name that you're actually going to use is the Sentinel-3 imagery. Then you specify the time range. You also specify the tidal range, which will actually explain it along the cells when you reach them. So after specifying your latitude and the longitude, which is actually very important, because that's if anywhere that you are going to work with, these are the areas that you should change to be able to execute it. So after getting them, then you display it on the results. Then the next step, what it actually does is to load the Sentinel-3 images that we are going to work with. Take notice at this point, you notice that we are only loading the red and the near infrared bands because we are only interested in, because we are going to use it to calculate NDVI. You don't actually have to load all the bands, but you only load the measurements or the tools that we are actually interested in. Those are the only two that you want to load. That's why we are loading the red and the near infrared bands. But if you want to load the other red bands, you can also load them here by adding those other bands to it. So for instance, if you want to add the green and the blue band, you just bring your comma, then you type the green band here, and you type your blue band here. But if you notice that those bands, you won't actually need them, but only those two bands you want, if only these two bands are the ones that you want to use, just specify those other bands. Doing that also will also preserve most of your memory because only the ones that you want to use are the ones you are going to get them. So for that area of interest, you load the band. Then you notice that between 2017 and 2020, we were able to have 338 time steps returning. And if you look at the time, notice that it started from 2017 January up to 2020 ending. After doing this, the next task is to load the global mangrove watch. Why are we loading that? Within the next cell, it will actually explain why we also loaded the global mangrove watch. So after loading it, we plot the mangrove around that area to see how the global mangrove watch data sets actually look like. And as you can see, look at the code, the product name, JMW. That's it for the product name. So right now we've loaded our Sentinel image and we've also loaded the global mangrove watch. We also have the modal tide height. The main reason why you wanted to use the modal tide height was, if you look at the description, they explain that the location of the shoreline can vary greatly from low to high tide, which may impact the NDVI values of pixel, where water and mangrove intermingle. So we want to reduce the effect of tides by modeling the tidal height data and keeping only the satellite images that were taken at a specific tidal condition. So that's why we are using the model tide heights within the code. So after applying the model tide height for the latitude and the longitude of that same area, previously we noticed that the data set that we loaded was 338. But if you apply the model tide height, you notice that right now you are going to get 168 images being returned for us. So this actually let us know that we've actually been able to prevent the high tide. We've been able to prevent the low to high tide waves from intermingle with our data sets. So using that, actually also we'll be able to do the reduction for us. So from there, right now, what we can say that we have the noise-free summary images. So from here, what we would do is we would do the computation of the NDVI using the calculate indices. The calculate indices is an already inbuilt library that comes with the Digital Earth Africa. And you just provide the data sets, then you provide the index that you want to work with, then the collection type, then it will do the computation for you. So once it does that, the next step is just to plot the years that we have here. So right now, you've actually used the NDVI to calculate the mangroves, to determine the mangrove within the sentinel. The next step that we want to do is we want to max areas that are mangrove as it conforms with the global mangrove watch. So this line here, the line 15 here, what it does is it makes sure that the result that we've gotten here, where the mouse is hovering, actually matches with the global mangrove watch current data sets, so that you'll be able to just identify areas that are determined as mangrove. So that's what we are doing here, combining the mangrove with the NDVI data that we already have. So after the masking, we will try and group our data sets into two categories. Areas greater than 0.4 are determined as mangrove areas. Areas below 0.7 are determined as regular mangroves, and areas above 0.7 are determined as closed mangroves. So these ones are determined. After that, we apply that formula that we just did here. So the first one is to determine all mangroves, which is we classify it greater than 0. Then from getting all the mangroves, the next one is we try to find regular mangroves, that's those below 0.7, and those above 0.7 are closed mangroves. That means they are always there. Then after getting these values, what you do is you plot them using this area, using this particular function. Then you'll be able to see the real mangrove areas. So as you can see, the yellow ones are regular, and the green ones that you see in between are the closed mangrove, and you can inspect them along the way. Then the next one is actually the mangrove change that you want to also know. So within the mangrove change, you are going to do a calculation on it. Then you see that the regular mangrove classification over time. So these, the blue ones are the regular mangrove, and the closed ones are just below, as you can see. So these are mangroves that hasn't been touched, and these ones are already there. So after getting this chart, also gives you an idea of what is happening. The next one is to quantify the results. And we are going to quantify between 2017 and 2020. So as you can see, so the green ones that we are seeing is new mangroves, the pink one are loss of mangroves, and the orange one are the stable mangroves. So you determine the next change between the years. And from here, you notice that the change in mangrove between 2017 and 2021. So the blue one is the delta change. That's between the new and the lost mangrove. So you have the no change, and we have the new mangroves, and we have the loss of mangroves. You can actually do the advanced comparison mangrove extent to 1996. So you can still do it and compare between 2017 and 1996. And you can still plot it, and you see the new changes. That's the new mangroves, the loss of mangroves, and the stable mangroves. So this is between 1996 and 2017. Then you plot it also out. So you can see the loss of mangroves, the new mangroves, the no change, and the delta change. So this notebook is also actually available for everyone to use. the area of interest that you want to work with is actually the most crucial part. So what you do is to change the latitude and the longitude of that particular area, then we can work with it. So this is how the mangrove analysis and the global mangrove watch dataset is currently being used within the platform for its usage. You can actually also bring an area of interest that you'll be happy for us just to run the notebook on it and see the results. So thank you very much. Please, any question at this point? But before that, please, if you have a latitude and longitude of a mangrove area that you'll be happy for us to look at it, we'll be happy. You can share it with us within the chat. Then you can run it for a particular area on how it's being done. Then you can pick it up and also run it at your own end. Thank you very much. Please, any question?
I have a question.
Yes, Majero.
Thank you very much for your presentation. My question is on the area of interest. Is it always the coastline for like the whole country? Okay, let me express it differently. How small can you zero in on the area of interest to get also get like a good result, like a good overview of the situation?
Okay, because you are using the Sentinel-2 imagery, the resolution is 20 by 20. So at least you have to, it has to be within that resolution, that 10 by 10 or 20 by 20. So once the image is within that, you'll be able to get a great result.
Ah, okay.
Yes, please.
Thank you.
Okay, welcome, Majero. Please, any question? If probably you have an area that you'd like us to run quickly, you can just share it with us. Then we can just run it quickly. Yes, Stella.
Edward, this is a nice presentation. I just had a question on the threshold values of determining whether it's a mangrove or not. Is it a universally accepted threshold value? Yes, I think it's this one where you put all mangroves and then regular mangroves or closed mangroves. Like, how did you come up with the threshold values, or is it an universally accepted threshold values?
Okay, with this one, I think it depends on the area that you want to work with. So right now you can stick with this one, or depending on the area, if you notice that this threshold can help, you can actually change it.
Okay, okay. And then my second question, at the beginning of the introduction, you mentioned the change of using also Sentinel-1. Are we using also the same Python notebook, or we have a different one for Sentinel-1?
Please come again.
At the beginning of the introduction, you mentioned we can use the same using Sentinel-2 and Sentinel-1. So I just needed you to answer, I just needed to ask whether we can use the same notebook for Sentinel-1 or there's a different one for Sentinel-1.
Oh, okay, sorry, then it's actually available for only Sentinel-2 now. Currently, we don't have it for Sentinel-1. So
Okay.
probably we can look at it, and if possible, we can work around within the Sentinel-1 area, but currently it's only for Sentinel-2.
Okay, thank you, Edward. Okay.
Okay, is any other question? Okay, so
I have a question.
yes,
even though we are landlocked, we don't have mangrove, but we have these transboundary basins that we also share. We are also like sharing with our neighbors, so we are part of the mangrove community. So I want to know about those change detections that you made when you say, you were telling that there's a change in, when you calculate the change in the amount of area. And then you showed a graph there. So there was like a bar, those bars that you were showing. Is it the total area? You went through it quickly, I couldn't figure out how. If you can probably just go through them again. Yes, those ones.
This one. Okay, so yeah, that's the total area. So what we're actually doing is we want to calculate the area where there's been a change, no change, and also new mangroves has appeared over the period between 2017 and 2021.
No, that's fine. I didn't see the that actually, because I just saw the bars. I didn't see the label for the axis. So it's the area in hectares.
Okay, Doc. Thank you very much, Doc. So you'll be happy if you can, depending on the area that you are working, you can get hold of the notebook. Then you can change the, so mind you, if you change the latitude and the longitude here, please scroll down also and change the tidal post and the tidal post lat and long. You also have to change this latitude and longitude also, so that you'll be able to, the tidal model can be applied on the image that you are working with. So you should also take notice of that. Okay, so this is where actually I'll end my presentation. If no question, thank you all for joining us today for the live section.